Hello, this is Brenda Wingard-Haynes, and this is Chem 110, Unit 6. In this unit, we're going to be talking about solutions, acids, and bases. You should have your blank notes in front of you, and you should be taking notes as I'm talking. Okay, if you need to pause the video, then feel free to do so. Also, please note that I'm at my house, which means you may hear my dogs barking in the background, you may hear my cats, you may hear the phone ring. It's just the way it goes. I would ask that we all just be flexible, go with the flow, and I guess we'll just get going. The other thing you should do is you should make sure you have a calculator handy, you should have a periodic table handy, a solubility chart, an electronegativity series, all those things that you would normally have if you were watching this in the classroom. Okay. Now we know what it means to be aqueous. Aqueous means dissolved in water. Okay? Aqueous means it's something that will dissolve in water, which means it's going to be soluble. So when you look at your solubility table, okay, so you may have had one that looks like this. S means soluble. Soluble means aqueous. Insoluble means it will not dissolve in water to a certain extent, and we're going to call that a solid or a precipitate. Okay, so as a reminder, if we have calcium nitrate in water, well, the first thing you need to do is write a formula for calcium nitrate. So calcium is a +2, nitrate is NO3 minus. 2 pluses means we need 2 minuses. So calcium nitrate will be CaNO3, 2, and it's going to be solid. Okay, so we're going to take that solid and we're going to put it in some water. Okay, now you're hearing my cat. And the question is it going to dissolve? Is it soluble? Well, on our solubility table, we see that pretty much all nitrates are soluble. Calcium nitrate is soluble, which means when we take that solid calcium nitrate and put it in water, it's going to be aqueous. Okay? Aqueous means that it is going to look like water. Okay, I'm walking away. I'm sorry. I'm going to see if I can find a visual aid. It's going to look like water. Okay? So, hold on. I'm going to get a visual aid. Okay, so aqueous is going to look like water. The calcium ions and the nitrate ions are going to be surrounded by water. Okay, and the way that we write that is to break this back up into the ions from which it's made, recognizing that that's going to be in water. So we're just going to emphasize that the calcium ion is surrounded by water. It looks like water. And we're going to have our 2 nitrates, and it too is going to look like water. Okay? Sodium acetate. Okay, so these are ionic, so you should know that ionic compounds are going to be solid. Okay, so all of these are going to be solid. Okay, so sodium acetate, we see sodiums are all soluble. Acetate is right here. Sodium acetate is soluble. Okay, so sodium, Na+, acetate, CH3CO2 minus. So our formula for sodium acetate will be NaCH3CO2. And it's going to be solid. It's ionic. Ionic compounds are solid. Okay, we're going to put that in some water. Our solubility table tells us it's going to be aqueous. NaCH3CO2, aqueous. That means it's going to look like water. My last thing of water had calcium and nitrate ions floating around in it. We just don't see it. On this one, This one's going to have, set that aside, sodium ions that are aqueous and acetate ions that are aqueous, and they are floating around in the water. That's why we don't see them. Just because we don't see them doesn't mean they're not there. Okay, so every time we made ionic compounds and I told you break them apart, break them apart, break them apart, break them apart. Well, the reason that I did that was so that we could understand this, because we are going to continue to move forward with this idea. All right, now some definitions. Solution is a solute plus a solvent. So what is a solute? That which is being dissolved or that component in lesser concentration. Okay, so concentration, that's now a new unit. Okay, so if I take my water and I put some kind of, say, sweetener in this, okay, so I got some stevia. What's my concentration now of stevia in that solution? Okay, the stevia is my solute because I only have a little bit of it. And then we're going to want to quantitate what the concentration unit is. So that's giving you a bit of a clue about what's going to come next. Solvent is that which is doing the dissolving. Or that component in greater concentration. Okay, so there's concentration unit again. Okay, so now in my stevia water, the water is the solvent, and we're going to call that aqueous. Okay, we're going to call that aqueous. Aqueous when water is the solvent. Okay, now most of the time we're interested in aqueous solutions, but not always. Okay, solubility is the ability to dissolve in a solvent. And before we just said yes or no. We looked at our solubility table. Our solubility told us yes or no. But now we have a new unit. Okay? We can also say, or X grams of solute per 100 grams of water at a certain temperature. And that's how we're going to quantitate the extent of solute that we can put into a solution. Saturated, the maximum amount of solute at a given temperature. Unsaturated is less than max solute at a given temperature in a particular solvent.